Good afternoon, everyone. Welcome to the first day session of Natural Language Processing for the Beginners workshop. On behalf of Department of Information Science and Engineering and VVC, I welcome all for this workshop. Today we have the first session from Dr. Roshan Fernandes. It's my pleasure to introduce you to Dr. Roshan Fernandes. Sir has obtained his bachelor degree in Computer Science and Engineering from Manipal Institute of Technology in the year 2001 from Mangalore University. He has obtained his master degree in Computer Engineering from SJC Mysore in 2007 with first rank. He obtained gold medal from VTU Belgaum for his MTech degree. He has obtained PhD degree from VTU Belgaum in the year 2019 in the area of mobile web services. He has working experience at NITK Surathkal and PA College of Engineering. He also worked as a project trainee at Motorola India, Bangalore for about 1 year. Currently, Sir is working as an associate professor in the Department of Computer Science and Engineering at NMAMIT Institute of Technology, Nitte. He has about 17 years of experience at NMAMIT, Nitte. His area of interest include data mining, mobility, mobile application development, machine learning, data analytics, natural language processing, and algorithm. He has published several research papers in IEEE Springer International Conferences and 7 research articles in the reputed international journals and published about 3 book chapters. He has delivered several technical talks on data analytics with R, natural language processing using Python, machine learning using Python, mobile and web application development for students and faculties. So it's our pleasure to have you with us, sir. Over to you, sir.
Thank you, madam. ಧನ್ಯವಾದಗಳು. Am I audible?
Yes, sir, you are audible.
Yeah, okay. So my sincere thanks to the convener, Dr. A.B. Rajendra sir, and the coordinators, Professor Prema madam, Professor Yashpal Gupta, Professor Vijay, Professor Kasturi Rangan, and Professor Sneha Shetty for organizing and coordinating this workshop and giving me an opportunity to interact with the young minds. So today's session, it is on introduction to NLP. So I'll be covering the basic concepts which are related to NLP. So once you attend this particular session, you must be able to understand so almost all fundamental concepts. So any research topic you take, so it is a must that you need to understand the fundamental words or keywords or the techniques which is used in that particular area. So that is my intention. Once you understand and make your basics strong, I think when you read the research articles which is written by different researchers across the world, it should not be a problem for you to understand the concepts and try to implement the ideas whatever you have. So with this brief introduction, let me start with the session. So for my session, whatever the content I have put it in my slide, the references are majorly from Coursera material and few research articles and research blogs, and of course a standard textbook I have referred, that is a Jurafsky, which we call it as the Bible of natural language processing. So what is natural language processing? Natural language processing, you cannot say that it is purely related to computer science and engineering. It is interdisciplinary field. Basically, you want to learn something about natural language processing, you must have very good idea on the language whatever you are going to work on, and at least some hold on the computer science and engineering concept. So as I mentioned, it is an interdisciplinary field concerned with the interactions between computers and human natural languages. Example, it could be English, it could be on speech, English speech or text. So for example, I have given here it is only English, it could be any other languages. There is a lot of work has been done on the English language, and there are few local languages, like for example in our coastal area we have our local language as Tulu, maybe Konkani, and when you move on to say Madikeri side, Kurg language or whatever it is. But again, English, there a lot of work is done, and ನಮ್ಮ ಕನ್ನಡದಲ್ಲೂ ತುಂಬಾ work ಆಗಿದೆ. So in Kannada language also there's a lot of work is done. But if any young minds are wanted to work on the languages which are not explored, so they can definitely work on that. So basically NLP is just to try to understand the language and the algorithms available in computer science and engineering to solve those problems related to natural language processing. NLP powered softwares, we are always using those particular NLP related softwares knowingly or unknowingly in our day-to-day life. So we may use some personal assistant like Siri, Cortana, and Google Assistant. Autocomplete in search engines or in our emails and all. Now you see in Gmail autocomplete. So whenever I say wish, say warm greetings, and then I try to reply to a mail, it gives me autocomplete. It suggests me what could be written in that particular email. Spell checking almost everywhere in the browser or in various IDEs or our word, anything you consider, there will be automatic spell checking. Sometimes it will correct automatically, or it may suggest these are the possible correct words. And of course machine translation. If you see in your Facebook or anything you write in Kannada or any other languages, it will translate to say English or from English to Kannada. So that is also we are using day to day in our day to day life, machine translation. So what are the natural language processing use cases? Chatbot. So I hope all of you are aware of what is a chatbot. So chatbot plays a very important role in web designs, right? No, so most of the times it so happens that the user will be having so many queries, and the admin of that particular web portal may not be able to send back the responses to all the users, and in that case an intelligent chatbot could be developed. So one best example I can give you is, say, I am the placement coordinator for our department in this institution, and there will be lot of queries from the students coming to me every day. So they send me so many messages, sir, whether what is the criteria for this company, whether I will be eligible to write this test, or what are the salary packages, and what is the work culture of this company. So there's so many queries students will be asking, and sometimes it is very difficult for me to answer all their queries. So probably if there is a intelligent based chatbot was developed, and that chatbot can answer on behalf of me, I think probably the two things. So like for example, the students may not be aware that who is responding back, but at least that intelligent chatbot is whatever is designed is giving back the responses. There are challenges, of course. Can you have a open domain chatbot? Difficult. But I can have a very specific. For example, now I say that only placement related activities I can develop a chatbot, because I can specify some rule based sentences so that the students can type those sentences in that form and then give me the request, so that my chatbot will understand what the students have written in that particular English sentence. Then the system will easily respond back. So another use case is, of course, sentiment analysis. A lot of papers you find on the web nowadays on sentiment analysis. So we take any product or anything you would like to buy. What we do is always we would like to see the ratings or the reviews. It's very difficult. So for example, let us assume that there are so many reviews present in for a particular product on the web. So maybe on Amazon or on Flipkart or whatever it is. So there should be an automated system which analyzes all these reviews. It not only suggests me whether that product is good or bad, it also gives me the aspects, what part or what component of that particular device is good or item is good. So what are their drawbacks? So it can suggest me and give me a summary of that particular analysis. That would be good enough. Then we have text classification. Say, let us assume I have a huge document, or the data, huge data is available with me, and I would like to classify the entire text as, say, maybe related to medical only, and then related to sports, related to movies, politics, recent trends in Twitter, or whatever it is. So these are all the use cases of the natural language processing. So as I mentioned on the first slide, what is natural language processing? It is not only related to computer science and engineering, or it is not only related to a very specific language. So it is basically a blend or a combination of the language as well as the computer science and engineering concepts. You can see here there is some intersection between these two. I need not be an expert in linguistics, or I need not be an expert in computer science, but there should be some common blend in between the language and the computer science algorithms. So with the knowledge of linguistics and with the knowledge of computer science, one can solve the problems related to natural language processing. Now, applying AI and machine learning will make those particular problems more beautiful or more intelligent ones. So that is the concept here. So first you need to understand the language concepts. Then, of course, what concepts are required from the computer science perspective to solve that particular problem, and then making this, adding masala to a food, taste powder and also, that is what is AI and machine learning will do, and then make the problem more and more intelligent. So in this presentation, I'm not going to explain you how to apply machine learning on natural language processing. Probably I think on third session, Shashireka madam will be going to highlight how do you apply machine learning on natural language processing problems. So today my intention is to make you understand what are the components of computer science which are needed to solve the language problems. As I mentioned, the same thing I mentioned. So NLP is divided into two fields, linguistics and computer science. Linguistics is concerned with the language, its formation, grammar, ವ್ಯಾಕರಣಗಳು ಅಂತ ಹೇಳ್ತೀವಿ ನಾವು, grammar, syntax, meaning, how do I frame the sentence, different kind of phrases, it could be noun phrases or verb phrases, how they are formed, whether the sentence starts with a noun phrase and then followed by a verb phrase, or the sentence starts with the verb phrase and followed by a noun phrase. So that rules and regulations should be known. And then the computer science, of course, is concerned with applying this linguistic knowledge. So how do I store this particular data? So what are the various operations I can perform on this data, and how computer science algorithms are used for transforming it into computer programs, and then how do I make it more intelligent by using AI or machine learning and deep learning. So if you consider the scientific advancements in natural language processing, which can be divided into three categories. One could be rule-based system, one could be classical machine learning models, and deep learning models. Of course, we have something called reinforcement learning also, which could be applied on natural language processing. So there are very few articles which are on reinforcement learning, which are applied on natural language processing. The young minds who are doing the research, please look into that concept also. Reinforcement. How do we apply reinforcement learning on natural language processing? What I mean by rule-based systems? As I mentioned, let us assume that I would like to develop a chatbot. So whenever I want to like to develop a chatbot, I usually specify to the customer. Say, for example, I cannot ask him to type a random sentence. Probably, I will request him to specify the request in a specific format. In a specific format. So that could be a rule-based system. But the rule-based systems may not work properly whenever we will give a random sentences, because whenever we give random sentences, it may not match with our rules whatever you are set up, and hence my designed algorithm or the specific model may not be giving you the proper accurate results. And hence we move on to the classical machine learning models. When I say classical machine learning models, we have various machine learning models starting with linear regression and all various categories of regressions. And then we have our naive Bayesian model, maybe support vector machines, where nearest neighborhood machine, and your unsupervised techniques like clusterings, any various types of clustering techniques, including k-means and all other clustering techniques. And then you may have even, of course, neural networks also. So, but the problem with these classical machine learning models is that there's a lot of human interactions involved, because we need to give as much as training as possible, and then the system will give me some better results. So people started going for deep learning when you have huge amount of data, okay. And then in the beauty of deep learning models is that, so human interventions in the interactions in the training process is very less because the system itself tries to learn itself and itself, so and gives you more accurate results, which works well on the huge amount of data. So these are the three categories, and there is of course the reinforcement technique, which you can explore more on that. So as I mentioned, rule-based systems, they heavily rely on the rules. How do I specify grammar rules or regular expressions? So how do I extract the structured data from the unstructured data? So due to the complexity of human natural languages, rule-based systems fail to build models that can really reason about language. So rule-based systems will fail whenever you have some random kind of sentences generated. And as I mentioned, classical machine learning models can be used to solve harder problems which rule-based systems cannot solve. So all machine learning models are probabilistic models. So you cannot say that it is perfect. You can say that this is fine or this works only with this probability. So as I mentioned, few of the things, the statistical machine learning model, various models, it could be naive Bayes or any other things which I mentioned. So here we have, since it is, it could be supervised as I mentioned, or it could be unsupervised, where I specify a large amount of data and I use some part of that as training and as well as testing data. So deep learning models, as I mentioned, are the hottest part of NLP research and applications now. They generalize even better than the classical machine learning approaches as they don't need handcrafted features, as I mentioned, because they work as feature extractors in an automatic way, which helped a lot in building end-to-end models. So the human interaction is little in the case of deep learning models. Suppose I would like to work on NLP. So what areas I need to concentrate on? There are so many things available which I cannot write because I am not that expert as I can say you, but I have gained some little knowledge when I worked on this particular natural language processing, because one of my research component was on the natural language processing itself, which I'll be highlighting bit later when I explain you the Markov chain models. What was that task I taken and what was the solution provided for that. But there are various open problems available, and you can take most of the data you can take is from the Twitter itself, because Twitter is the one, and Facebook or WhatsApp is the one which generate enormous amount of data. And now people want on the fly analysis, on the fly live. So whenever there is a Twitter coming, immediately on the fly you can give the analysis. So such type of tasks or analysis is necessary nowadays. So if you work on that, and then you can use the various big data handling tools such as Spark, and then live streaming of data through Twitter, and then you analyze on the fly. Probably those particular works can have more weightage. So we'll quickly look into what are the tasks and research, mostly solved spam detection in email, Gmail. So this could be best used is our maximum entropy models to solve this particular spam detection. And then we have those problems on parts of speech tagging. So nowadays, even if you consider for the standard languages, for say English, we don't have any, I mean, we need not design an algorithm for the parts of speech tagging, because we use simply the APIs, because the parts of speech tagging is already been done. But for the languages, I mean, which doesn't have much resources like our local languages, probably you may need to design something related to parts of speech tagging. And those problems for standard languages, these problems are solved, but still for the local languages, these problems are still open. So given a sentence, determine parts of speech tags for each word. It could be noun, verb, adverb, adjectives, etc. And most of the time, the best model used to implement the parts of speech tagging is hidden Markov model. I have it in my slides later. Probably if I can complete my talk by 4:30, we will see. I can just give you the highlight how exactly hidden Markov model works. And then there is a problem on named entity recognition. Given a sentence, determine named entities, example, person names or locations or organizations. So this could be used in most of the you develop some chatbots or some mobile apps or web-based apps, intelligent enough, definitely intelligent enough, which are related to tourism. So if you have anything applications which are developing on tourism, probably these named entity recognition can help you a lot, because there we need to give so many recommendations, and based on what recommendations people start writing the reviews, and in that probably reduce in the tourism or the hotel or the restaurant systems, probably we need to identify what is the location, what is the food item, and all those things. So that can be analyzed using named entity recognitions, making good progress. As I mentioned, there are a lot of work going on right now. You can find, if you open Scholar or any journals, I think there are so many papers you get on sentiment analysis. Okay, and then co-reference resolution. Given a sentence, determine which words mentioned refer to the same objects. For example, so Manning is a great NLP professor. He worked in academia for over 25 years. So I just wanted to refer here. What is he is referring to? He is referring to Manning. So that's co-reference resolution. And then word sense disambiguation. So many words have more than one meaning. For example, now I can say I went to the bank to get some money. So probably this bank can be referred to a finance institution, or probably it can refer to a land beside a river. Even machine translation is in good progress. You can see Google Translate, or Google does more accurately. In fact, of course they have their own algorithms, but still we can also contribute something on machine translation on our local languages. Probably for on English there will be a lot of work done, but we can concentrate on our local languages and then try to contribute something for them. Still a bit hard or open challenges. It could be dialogue agents and chatbots, especially open domain ones. As I mentioned, developing a chatbot, rule-based chatbot for a specific domain is quite easier one. As I told, it could be only for a institutional website where the queries comes only on some say admissions or placements or whatever it is. But open domain one, say I have a chatbot which can give me the answer for politics, finance, education, and all those things, which is really challenging. Question answering system. So this is information retrieval. So I impose a question onto the system and then it is giving me an answer. Content summarization, it's again a beautiful concept. Again, we are not getting much content or the research papers on this. We can have, again, still you can get much more accuracy for the content summarization. Again, there are so many techniques used on this content summarization. This is a separate topic, probably we can take sometimes in future probably. So here it could be some probabilistic models. You have, say you have a huge document. Usually what we do as students or as people, what we do is, instead of reading an entire textbook, we go to our colleagues or we go to our friends or peers, and then we ask them, could you give me the summary, so what exactly it says. So probably those who know and already read and which can be given it, which who can give you a summary, I think probably it saves a lot of our time. You might have observed that right now. So even I can ask my computer or system to give me a summarized report. Say I have a storybook or a newspaper which is having some 10 to 15 pages. I am not having time to read everything, so I can give my system, please give me the summary of that. So, and giving an accurate summary is really challenging. And as I mentioned, develop a natural language processing system for low resource languages. As you can mention, in Karnataka, again in coastal areas, if you can listen, we have Konkani and Tulu, and then you can have Madikeri ಅವರು ಅಲ್ಲಿ ಆಚೆ ಹೋದ್ರೆ ಪುನಃ ಕೂರ್ಗ್ ಲ್ಯಾಂಗ್ವೇಜ್ ಅವ್ರು ಏನು ಲ್ಯಾಂಗ್ವೇಜ್ ಯೂಸ್ ಮಾಡ್ತಾರೆ ಅದ್ರ ಮೇಲೆ ಕೂಡ ವರ್ಕ್ ಮಾಡಬಹುದು. ಸೊ ಆರ್ ದ್ರಾವಿಡಿಯನ್ ಲ್ಯಾಂಗ್ವೇಜಸ್, ಈವನ್ ಸಂಸ್ಕೃತ್ there is some work has been done, ಕನ್ನಡದಲ್ಲೂ ಆಗಿದೆ. But for low resource languages, you can take up some work on those languages. So what are the various steps involved in natural language processing? Even now, whatever the natural language processing problem comes, it could be anything. I'm doing content summarization. It could be machine translation. It could be pronoun resolution, or it could be sentiment analysis. Anything it could be. Okay. So In general I can say we can apply these particular steps, but I cannot say that we need not apply all of them, but typically we apply this. So first step we apply is lexical analysis. This is compulsory, I mean, for all natural language processing. This is the first step we apply. So if you have studied compiler design, probably there also we talk about lexical analysis, syntactic analysis. Yes, true, semantic analysis. There we were talking about a language. Okay, there the language what we are talking about programming language, and here the language what we are talking is on the natural language, that is human language. It could be English or it could be Kannada. So what the lexical analysis will do is you have a huge text document, or it could be speech also, which can be again represented in different forms. So if you consider a text which is having a huge document having a text, and then what we initially do is we break this particular document into sentences, and sentences into words, and words into characters. But here in natural language processing, it's enough if you break the document into sentences and then words. We don't have much importance of each characters in natural language processing. So that is taken care by lexical analysis. And how do we do that? We apply the regular expressions to break the entire document into words. Then we have syntactic analysis here. So what exactly is the syntactic analysis? So most of the times in natural language processing, we skip this. So you can see any papers or research papers, and you read yourself. Probably this part would be missing in majority, but still you can take up this also as a part of your analysis, so which can give you some little bit more weightage on this. So why do we need to check the syntax of a particular sentence? So probably I can give you an example. Say for example is one simple sentence I can say, uh, the goat goes to school. The goes to school. So probably I think that sentence syntactically is not correct, because it says that the sentence framing should not be in that way. The goes to school. So probably there should be some noun or pronoun. So instead of that, we don't get that particular noun or pronoun. Instead of that, we get the word as the. Syntax error. So such sentences, you can say that there is a syntax error on this particular sentence, and then you can suggest, probably in this sentence, probably you would have suggested, because you know the rules and regulations for a particular language, probably you would have suggested, look into this, probably instead of the, probably you would have written some noun or pronouns or proper nouns, whatever it is. So that is about syntax analysis. Again, you have top down and bottom up approaches here, which I'm not going to cover in this session. Separately, if you'd like to have, I have written some documents, notes, and I can share you later if you want. And the next one is important. Yeah, this is where we need to concentrate as a researcher, is semantic analysis, to find out the meaning. So in syntax, we don't get the meaning, we get only the syntax, or how the formation of the syntax, I mean formation of the sentence as per the rules and regulations is concerned. Okay. Uh, Next, yeah, in semantic analysis, as I mentioned, we are trying to get a meaning of that particular sentence. So all our sentiment analysis, all these things, whatever we have, some content summarization is coming in this particular area, that is the semantic analysis. Next, we have is something called discourse integration. So we call it as pronoun resolution also. Example is Ramesh is eating ice cream. Or you can say that Ramesh is eating ice cream, and I can say that Sham liked it. Ramesh is eating ice cream. Sham wants it or liked it or whatever it is. So that it refers to that particular ice cream. So that is what has to be taken care in discourse integration. And then there is something called pragmatic analysis. So when I say some example, say close the door. Okay, there is some sentence in speech or whatever it is. Probably I think I can say that pragmatic analysis gives more importance in speeches. When I say close the door, so it's an order or a request. So the pragmatic analysis does that. Okay, so these are the various steps. So we will be concentrating more on this lexical analysis and semantic analysis, and just the introduction on this, because I'm not going to spend much time on this, because our area to concentrate in this topic is lexical analysis and semantic analysis, how it is performed. Just the same thing whatever I explained, so I'll, with your permission, I'll just skip these slides. Discourse integration, then pragmatic analysis. Yeah. Now let us look into various keywords used in NLP. First one is, what do you mean by tokenization? Tokenization is generally an early step in the NLP process, a step which splits longer strings of text into smaller pieces, or we call it as tokens. It's a process or outcome of the lexical analysis. So larger chunks of text can be tokenized into sentences, and sentences can be tokenized into words. As I mentioned, we are not further processing these particular words as say characters, because most of the time the words are enough for us. Normalization. So what do you mean by normalization in a typical natural language processing system? So whenever you collect some text from the web, it could be from the web, it could be from the various online retailers, something like say Amazon, or it could be from anything, or Twitter data. So when you take the data, it is not normalized. Some words will be in the uppercase letter, some of them will be smaller case letters, some of them will be mixed, some of them will be having special characters and all those things, punctuations, a lot of punctuations will be there. Some of them will be having short names, smileys, and all those things. So what the normalization step, this is very important. You do any natural processing process, problem solving, normalization is compulsory. Please make a note. When you have some data set when you received, you have to apply pre-processing, and one of the pre-processing you have to apply is normalization. So normalization generally refers to a series of related tasks meant to put all text on a level playing field, converting all text to the same case, maybe upper or small case, removing punctuation, because these punctuations and all, they do not contribute much on analysis of these sentences or meaning of these sentences. Then expanding contractions is important, and sometimes you need to convert numbers to their word equivalents and many more. So normalization puts all words on equal footing and allows processing to proceed uniformly. So that's all about normalization. Then a very important term we use in natural language processing called stemming. Stemming and lemmatization are the two very important parts used. I will tell you why do you need stemming, what is the importance. Stemming is the process of eliminating affixes from a word in order to obtain a word stem, so root of that word. So what are the possible affixes for a particular word available? It could be suffixes, or it could be prefixes, it could be infixes and circumfixes. If you consider English language, other languages, if you see, very two, German language and Indonesian one language is there. In that you have some uses of infixes and circumfixes, but majority for English we have only suffixes and prefixes. What is stemming? So for example, now you have a word called running. Now you stem it and just bring it to run. Now the immediate question you may ask is, sir, why do you need to convert from running to run? Why can't I keep it as running only? Let us consider one example. You have a training data set of a set of words or set of sentences. You cannot predict what type of words come there. You may get some word as run in the training data set. You may get some word as running, some word as ran, and some relevant words. Now, for example, as per my knowledge is concerned, for run, you may be getting only these three: running, ran, or run, something like that. But if you have more, if you consider the present tense, past participle, and all those possibilities, the meaning, ultimate, what I'm going to say is same. Say, for example, run. They're all related to a word called run. Okay. So now, suppose you have these three words appearing in your training data set: running, run, and ran. So probably when I were to analyze my, say, when I apply the machine learning concepts, so for example, I'm trying to apply, say, naive Bayesian on this. And when I apply naive Bayesian on this, I need to see that the three different words appear in the training data set. They are running, run, and ran. And then I need to, so what happens is my word count in fact increases. So for example, each word is having three forms and four forms sometimes and all those things. So unnecessarily I'm increasing the training data set unnecessarily. So in that case, what I can do is, instead of running, I can make it as run. So then all related. So for example, now ran, I'll replace it to run, and then run as keep it as run. So three times I had this particular occasions, running, ran, and run. I'll keep only one word in the training data set. So that is the advantage. Okay, so that's why we need to apply stemming. Otherwise, stemming is not necessary. Otherwise, stemming is not necessary. Okay. Now, as I mentioned, there could be some prefixes or there could be some suffixes in English language. So prefixes precede the stem, suffixes follow the stem, circumfixes do both, and infixes are inserted inside the stem. For example, the word eats. See, eats itself, you can see eats, eating, ate, eat, all these are related to that. They should be, I mean, once you apply stemming, they should be moved to only one word called eat. So, for example, the word eats is composed of a stem called eat, and the suffix is yes because it comes at the end. So that's why you call it a suffix. Now it could come in the beginning also, prefix. So the word unbuckle. So buckle is the root, I can say, stem. Unbuckle. So you have to remove this particular and then make it buckle. English doesn't have any good examples of circumfixes, but many other languages do. In German, ಒಂದು example ಕೊಟ್ಟಿದ್ದಾರೆ. In German, for example, the past participle of some verbs is formed by adding ge to the beginning of the stem and t to the end. So here, what I'm doing is you're putting something to the beginning and you're putting something to the end. Okay. So the past participle of the verb sagen. Sagen is something said to say, and said is written something like this. So they are adding g at the beginning and say t at the end. So something like this. And then infixes, in which, so there again the natural language processing pre-processing would be much difficult. So how do you apply stemming for such a situation? Imagine. So we are lucky enough if you are using English or Kannada ಆ ಥರ ಬರುವುದು ತುಂಬಾ ಕಷ್ಟ. Okay, very rarely we get such situations. So infixes in which a morpheme is inserted in the middle of a word occur very commonly. For example, in the Philippine language called Tagalog. So for example, the affix which marks the agent of an action, is infixed to the Tagalog stem hingi. Hingi is something like to borrow. To produce humingi, you can just see is inserted in between HINGI, but ಅಲ್ಲಿ ಒಂದು ಅನ್ನು ನಾವು add ಮಾಡ್ತೇವೆ. So I mean, so these languages makes the processing more and more difficult. Next, lemmatization. Whether stemming and lemmatization is same or different? Similar. So again, immediate question comes, sir, should I apply stemming or lemmatization, or should I apply both? That is left to you. So you have huge text, you can apply stemming, do the analysis, apply lemmatization, do the analysis, and say that yeah, when I done applied stemming, this is what results I got, and when I applied lemmatization, these what results I got. Lemmatization is related to stemming, differing in that lemmatization is able to capture canonical forms based on words lemma. Lemma means when you have more information related to that particular word, more dictionary information will be there. Whereas in stemming, it is not there. For example, stemming the word better would fail to return its citation form, another word for lemma. However, lemmatization would result in the following: better to good. But whereas stemming may not be able to give me this word better as to good. So that is the drawback of stemming. So differences between stemming and lemmatization. As I mentioned, stemming algorithm works by cutting off an end or beginning of the word for English, taking into account a list of common prefixes and suffixes that can be found in an inflected word. This indiscriminate cutting can be successful in some occasions, but not always. And that is why we affirm that this approach presents some limitations. Best example is in front of you. If you have studies, then the suffix it considered as es, and then the suffix it considers for studying is ing, and stem will give me study studi, and here stem will give me studi. This is right, but this is not correct. But whereas lemmatization takes into consideration the morphological analysis of words, so it has got more meaning associated with this lemmatization. It takes much memory, but still it gives me an accurate result. To do so, it is necessary to have detailed dictionaries, which the algorithm can look through to link the form back to its lemma. Same thing if you apply lemmatization, what is the results you are going to get? Studies. So there is some morphological information related to this particular word in the lemmatization. It says studies is a third person, singular number, present tense of the verb study, and hence the lemmatization process will give me for studies as the word called lemma as study. Studying, of course, it gives me study here, which is more accurate as compared to stemming. So all the pre-processing technique, I suggest better to apply lemmatization. But of course, for simpler language words, you can apply stemming also, and you can do your own analysis by applying these two and see which gives you more better results. So that's all about normalization, which very important three keywords you must know: normalization, stemming, and lemmatization. There is something called corpus. You might have heard what is a corpus. Okay, in linguistics and NLP, corpus. So basically, the corpus term came from the Latin word. Okay, so it's basic corpus means is basically meaning is body. Okay, it refers to a collection of texts. Such collections may be formed of a single language of text or can span multiple languages. There are numerous reasons for which multilingual corpora may be useful. So whenever we would like to analyze natural language processing, say pronouns, for example, pronouns are they are very few set of words which are present for pronouns. Okay, but whereas I cannot have a corpora of nouns. Noun could be anything. So, but whereas I can have some adjectives, a list of adjectives, a list of pronouns. So those particular words I can say they are called bag of words, or I can say it as a corpus. There are something called stop words. What do you mean by stop words? And why you want to remove them? Most of the times when we do the analysis, natural language processing analysis, as a part of pre-processing, we do normalization, we do stemming, we do lemmatization, and we do removal of the stop words. Why do you want to remove the stop words? What is the why we want to do that? We will see in this particular slide very clearly. Stop words are those words which are filtered out before further processing of text, since these words contribute little to overall meaning, given that they are generally the most common words in a language. For instance, the, and a, and. So while all required words in a particular passage don't generally contribute greatly to one's understanding of content. So what the stop word removal will do is, say for this sentence, the quick brown fox jumps over the lazy dog. You can just remove the. Now, what happens if I keep these particular words? Say, let us assume I don't remove these stop words. Okay, why should I remove the stop words? Let it be there. One thing is, unnecessarily we're increasing the burden on the training data set. So you have a lot of text as a training data set, and I unnecessarily use these particular terms, use these particular terms, use these particular terms. Unnecessarily we are using these particular terms. One example I'll give you. See, when we do this particular analysis, sentiment analysis, let us assume that I have a text and I would like to classify this particular text, whether this text is represents some positivity or whether it represents negativity. A simple example in natural language processing you can take. When I do this particular analysis, I can apply any machine learning algorithms on this, and then I can classify as it is negative or I can classify it as a positive. When I do so, when we use something called a term frequency, I will explain later today's class what is term frequency. And I do this particular term frequency for the quick brown fox jumps over the lazy dog. Okay, so that's for the training. And when I analyze, D is not contributing anything to the positivity nor negativity. So I can say that what is the contribution in terms of probability? Say I can say that the total conditional probability is contributing to positivity, say something like say 0.01, and then to the negativities also it is showing say something like 0.01. So there are some people who say yes for both sides. That is the similar situation here, and we try to remove all these words. That's why they are not contributing in judging whether this particular phrase of text belongs to positivity or this phrase of text belong to negativity. And such words which do not contribute in deciding which class the phrase belong to, it's better to remove them. Okay, so that's why we usually remove these particular stop words. That's the only reason. Yes. Now the next very important part is parts of speech tagging. So again, how parts of speech tagging is implemented, I'll be explaining later using hidden Markov model. But for English, if you're working on English language or some few standard languages, the parts of speech tagging is already built in. So there is absolutely no problem. No need to again design your own parts of speech tagger. Whichever parts of speech tagger is used, you use it in your programming languages as a part of API. But what exactly is a parts of speech tagging? It consists of assigning a category tag to the tokenized parts of a sentence. The most popular parts of speech tagging would be identify word as nouns, verbs, and adjectives. Of course, pronouns, those are required, but when I want to say whether it is a positivity or negativity, sometimes adjectives will contribute more on that. The universal parts of speech tags is here, adjective, some English examples, ADP, adverb, conjunction, determiner, noun, numeral, particle, pronouns, verb, and so on. Okay, some examples given here. So we'll check a little bit more on this parts of speech tagging later. Otherwise, the words, I mean, the definition is clear, I guess. Statistical language modeling. So what do you mean by statistical language modeling? So it's basically I'm applying the probabilistic models on the text analysis, and based on the probability I'm deciding what is the likelihood. So this can be especially useful for NLP applications which generate text. We have something called bag of words and n-grams. Okay, I think I have to give you the clear differences between n-grams again in detail we will see today. What is bag of words? Bag of words is a particular representation model used to simplify the contents of a selection of text. Okay, it could be a corpus similar to corpus. Consider the sentence: well said John, there said James, there. So I need this bag of words representation. We call it as a term frequency later. Okay, for as a part of this is a basic requirement for machine learning. Whenever I want to apply machine learning on this, so I apply this, use this bag of words, or I can use n-grams too sometimes. So the resulting bag of words representation as a dictionary I can consider like this: well repeated 3 times, said repeated twice, John repeated once, they repeated 4 times, and I think I missed something here. James repeated once. Okay, James colon 1. So I mentioned here it's useful in text classification using machine learning technique, which call it as term frequency. If you consider this with the n-grams, okay, you can just see here there is no relationship mentioned between first word and the second word. It simply says each word how many times repeated. Very simple. Okay, each word how many times it is repeated, but there is no relationship between established between the previous word and the next word, or previous 2 words and the next word, or previous 3 words and the next word, which is resolved in n-grams. So as opposed to the orderless representation of bag of words, n-grams modeling is interested in preserving contiguous sequences of n items from the text selection. That depends how many contiguous words you would like to consider. If you would like to consider 2 grams, 2 words, fine, call it as 2 grams. If you'd like to consider it as 3 grams, call it as 3 grams or trigrams, and so on. So if you consider the same example, so well said John, there said James, there. So how do you represent in 3 grams, for example? Okay, so any example you consider, there, said James, there. So let us not consider this well, said John. We will consider only this, there, said James, there. So how do I specify in a trigram? So I need to combine three words now. There, said, and then there, said James, and then James, there. Sorry, said James, there. So these are the possible trigrams I have generated for the sentence called there, said James, there. In detail about n-grams, I'll explain you later. Now you may ask me what is the difference between n-grams and bag of words. Now the difference is very clear. So here it represents a relationship between three words. So it says the next word of there is there. The next word of there is said. And you can always have what is the probability that after there, what is the probability that that word comes is said. Predicting when you type in our mobile phones or anything, next word predictions, no, that can be easily solved using n-grams with the examples we will discuss later. But whereas in the case of bag of words, it is not so. Bag of words is purely a collection of words which doesn't specify any relationship between each and every word. Regular expressions contribute a lot for the lexical analysis in natural language processing, which is used to tokenize the words. I'm not going to give you much explanation on regular expressions because all of you know, because we are studied in finite automata and compiler design, what is the regular expression. So we use all these operators, and of course when you use this natural language processing pre-processing, Python will support you a lot because there's NLTK tools used in Python, and all these can, whatever I explained so far, no, normalization, stemming, lemmatization, everything can be implemented in Python. So even regular expressions, you can just give regular expressions in Python code and it gives you everything for you. So I'm not going to discuss much on this particular slide. Let me skip this. There are some similarity measures. This is very important in natural language processing. As I mentioned, in natural language processing, you can use this particular natural language processing to correct the spellings. Say, then immediately in your sentence, for example, one word you say that is not in the dictionary, then it gives you some suggestions. If you see in Microsoft Word, no, if you right click on that, it underlines as red color, and it right click on this, it give you possible some uh, suggestions. How it gives you suggestions? So it performs some similarity measures. So there are various techniques on which you can apply similarity measures. One of them could be Levenstein, the similarity measure, Jacquard, and Smith-Waterman. Again, I'm not covering in detail because each one again takes a lot of time to explain. So I'm just telling you the overall. These are the similarity measures available. And then what is Levenstein? So it says the number of characters that must be deleted, inserted, or substituted in order to make a pair of strings equal. So now I have a word with the spelling mistake. Then I have another similar word, say, similar with the so many characters matching. So then I have to see how many characters I have to delete in this or insert or substitute in order to make this wrong word as equal to that particular correct word. So I need to see how many minimum number of deletions or insertions or substitutions are possible, and only those suggestions will be given. So it's not that when I type anything, random suggestions are given, no, which is quite similar. So that's why it says how many of them minimum number of deletions, insertions, or substitutions should be identified in order to make a pair of strings equal. So it could be Jacquard also, or it could be Smith-Waterman also. Okay, so Levenstein and Smith-Waterman are similar, but only the difference is Smith-Waterman adds costs. Here the costs are same. So for example, for deletion or insertion or substitution, the costs are same. I can say the cost is 1. Okay, or if I say in the time complexity, so for example, for deletion it takes 1 second, insertion also it takes 1 second, and substitution also 1 second. But whereas Smith-Waterman, it is not so. Your different costs are assigned. So substitution you assign say cost as 2 seconds, insertion 1 second, and deletion say 1 second. Syntactic analysis I already mentioned. Let me skip this. Then semantic analysis also, I think I talked on this. So it's basically on meaning generation, right? No, so it could be anything. I want to just summarize it, or I want to do a sentiment analysis, anything it could be. So I try to find out a meaning from this. It could be getting the emotions also. It could be on string or text. It could be on speech, or it could be on videos, anything. So this is also, I told you what is sentiment analysis. Okay. So basically sentiment analysis is the process of evaluating and determining the sentiment captured in a selection of text with sentiment defined as feeling or emotion. It could be, say, positive. I can say this is the positive sentiment, happy, or it could be negative, sad or angry, or it could be neutral, or it could be some more precise measurements along a scale with the neutral in the middle and positive and negative increasing in either directions. So we have something called information retrieval, question and answer system, I told you. So I am asking some questions to my system, and the question, my system is intelligent enough to give me the response back. So I mean, this is similar to chatbot also. Chatbot is asking a question. Can I write to this company? My CGPA is so and so. So my system, some semantic analysis, my chatbot system will understand, analyze the sentence given. Okay, so I'll try to find out some keywords which are necessary for me. For example, say company name and the CGPA, probably, which are useful for me. Some nouns, both are nouns. And then if you have some numerics, that also I'll take. And then I try to analyze the sentence, whether it's a question or whether it is a request or something like that. And then my system should be intelligent way. Should have some database for that the company. What is the CGPA? And that response, I'll form a sentence back and give that back to the user who has requested for the same. So that is the concept of information retrieval. Parts of speech tagging I already mentioned, because nothing much to explain on this. So we can always go for an API, and the parts of speech can be attached to each word of a particular sentence. So this I'll skip. There's the standard parts of speech tags. So most of I may not be using all the parts of speech tags here. Okay. So I may use most of the times what is required for me is adjective. What required for me is noun, pronoun, and sometimes verbs. Yeah, verbs also required for me. Some most of the times. So others are not that important as far as English is concerned. Okay. So you can do some analysis on this. The next very important concept in NLP is natural language generation. As I mentioned in the previous just slide just now, I mentioned in the case of information retrieval. Let us consider our scenario where I have developed a chatbot and the student writes a request for me. Okay, could you please tell me company XYZ, for company XYZ, what is the minimum CGPA? What is the minimum CGPA? So somehow my system will understand that the student requests for the minimum CGPA for a company name. Okay, these are the two components it fetches from that particular sentence in a semantic way. And then in my database, I have say company name, say XYZ, and what is the minimum CGPA. So I cannot give him simply like, say, for example, reply as say company XYZ CGPA, say at 8 or percentage as something like say 65%. It will become meaningless. So the user also will think what type of answer you are given it to me. Correct, no? So usually when we talk or whatever, we also expect some good response from others. Some good response. It's not that whenever I ask some questions, only one word answer. Okay, ನಮ್ಗದು ಚೆನ್ನಾಗಿರಲ್ಲ. So when we receive one word answer, we don't feel comfortable. So at least when I ask a question, it should be a proper answer. It's given, we'll be happy. So here also, so that only two words. So for example, company XYZ and the CGPA, something like say 7.5 or percentage say 65%, I can frame a natural language sentence. So that is very important. Okay, so how do you frame? That is again challenge, but you have to give in a sentence and then give it to me, give it to him. This is one scenario. There are some other scenarios. Say for example, let us assume there is a weather reporter system. Weather reporter system works only on numbers, right? No, so it may be humidity or temperature or anything. There are various factors. They works only on numbers, and then we need to generate some summaries of that particular data. So whenever you want to generate some summaries, you cannot simply give numbers. People will not understand when you just give the numbers. So there should be an intelligent system which can transform these numbers into sentences and then generate these sentences and give back to the users. So these are all the challenges. These are all the challenges where you have some number systems, and based on these number systems, you conclude something and frame some sentences and give back report generation. So we do it manually, right? Any event occurs, any cricket match or anything, we do it manually, but try to do it automatically. That is what is natural language generation. Again, this has got a lot of scope, a lot of work on, a lot of problems are available on this. You can search on this. Machine translation. Again, machine translation, as I mentioned, is the translation of text from one language to another using the system. Of course, there are challenges. When I translate, it is not that easy, right? No, because what are the challenges involved? Word order. Arrangement of words in a sentence varies across languages. This makes a word by word translation impractical. Now, if you consider any English statement, straight away, if I consider that one simple method of language machine translation is just look into dictionary and translate it and give the result. Okay, but it would be meaningless, because what happens is whenever I give you a sentence in English, same thing word by word, if I convert to Kannada, the Kannada sentence become worst, right? No? Or same Kannada text I have and I just translate the same way by adding English words to that, it becomes meaningless. So that is very, very important. Then second one is word sense. Simple technique, I told you, machine learning translation, simple technique is word by word translate and give the results, but it doesn't work. So we have that various, again, probabilistic models for that. I'm not going to cover up those things here. Word sense, again, the challenge. The sense of the word in one language may translate into a different sense with the words of another language. Example, consider the two examples of the distinct sense that exists for the word buzz. There are two sentences. Now let us assume I would like to convert this particular two sentences to Kannada. I can hear bass sound. So this is related to music, frequency, right? Now bass sound. And then he likes to eat grilled bass. So here the second bass is related to fish. This is the fish name. Here this bass relates to the frequency. So when you translate to Kannada, so here if it translates to fish and here it relates to frequency, so the meaning will get completely distorted. So one solution is you can use disambiguation. I told you word sense disambiguation, one concept came previously, we can use that. In that case, what you can do is word sense disambiguation. I can hear buzz, so attach a tag to that. What is buzz? Buzz, you are attaching a tag called frequency sound. He likes to eat grilled bass. Attach a tag called fish. And then you translate much easier. Pronoun resolution. Discourse, but we have talked that time. Same thing. Resolving pronominal preferences is important for machine translation. Unresolved references may lead to incorrect translation. Okay, so again we have a list of pronoun resolutions. Okay, so I'm not going to cover up here. Say for example, now we write a sentence. Ramesh likes to eat, say, ice cream. Okay, Sachin also likes it. So what that it refers to. So there could be different pronoun resolutions which may appear. Sometimes it may have some idioms. A sentence involving idiomatic expressions. These are the most challenges one, right? No, idioms expressions is difficult to translate as idioms are composed of words that do not directly contribute to their meaning. Example, now idioms we write, the old man finally kicked the bucket. If you translate as it is to Kannada, so ಏನಾಗ್ಬೋದು ಇಲ್ಲಿ, ಸೊ ಬಕೆಟ್ ಅನ್ನು ಒದ್ದು ಬಿಟ್ರು ಅಂತ ಅಲ್ವಾ, ಕರೆಕ್ಟ್ ಅಲ್ವಾ? ಬಟ್ ಬಕೆಟ್ ಅನ್ನು ಒದ್ದು ಬಿಟ್ಟದಲ್ಲ. ವಾಟ್ ಇಸ್ ದ ಮೀನಿಂಗ್? ದ ಓಲ್ಡ್ ಮ್ಯಾನ್ ಫೈನಲಿ ಕಿಕ್ ದ ಬಕೆಟ್, ಹಿ ಎಕ್ಸ್ಪೈರ್ಡ್, ತೀರ್ಕೊಂಡ್ರು ಅಂತ. ಸೊ ದಟ್ ಈಸ್ ದ ಮೀನಿಂಗ್. ಸೊ ಇಟ್ಸ್ ರಿಯಲಿ ಚಾಲೆಂಜಸ್ ಅಲ್ವಾ. ಅಂಡ್ ಈವನ್ ಇನ್ ಸೆಂಟಿಮೆಂಟ್ ಅನಾಲಿಸಿಸ್ ಆಲ್ಸೋ ದೇರ್ ಇಸ್ ಲಾಟ್ ಆಫ್ ವರ್ಕ್ ಇನ್ನೂ ಪೆಂಡಿಂಗ್ ಇದೆ. ಸೊ ಯು ಕ್ಯಾನ್ ಟೇಕ್ ಅಪ್ ಸಮ್ ಸೆಂಟೆನ್ಸಸ್ ಲೈಕ್ ದಿಸ್. ಸರ್ಕ್ಯಾಸಮ್ಸ್ ಅಲ್ಲಿ ತುಂಬಾ ವರ್ಕ್ ಪೆಂಡಿಂಗ್ ಇದೆ. ಯು ಕ್ಯಾನ್ ಜಸ್ಟ್ ಟ್ರೈ. ಸೊ ದ ಮೂವಿ ವಾಸ್ ಟೂ ಗುಡ್ ಟು ಸ್ಲೀಪ್, ಆ ತರ ಸೆಂಟೆನ್ಸಸ್ ಬರುವಂಥದ್ದು. ಸೊ ನೀವು ರೈಟ್ ಮಷಿನ್ ಲರ್ನಿಂಗ್ ಇಟ್ ಗಿವ್ಸ್ ಯು ಆಲ್ವೇಸ್ ಪಾಸಿಟಿವಿಟಿ. ಯಾಕಂತ ಹೇಳಿದ್ರೆ ಟ್ರೈನಿಂಗ್ ಡೇಟಾ ಸೆಟ್ ಟೂ ಗುಡ್ ಟು ಸ್ಲೀಪ್, ಟೂ ಗುಡ್ ಅಂತ ಬರುವಂಥದ್ದೆಲ್ಲ. ಸೊ ಟೂ ಗುಡ್ ಟು ಸ್ಲೀಪ್. ಸೊ ಬೇಸಿಕಲಿ ಹೌ ಯುವರ್ ಟ್ರೈನಿಂಗ್ ಸೆಟ್ ಈಸ್ ಆ ಥರ ಬರುತ್ತೆ ಅದು. ಬಟ್ ಸ್ಟಿಲ್ ಲಾಟ್ ಆಫ್ more intelligent algorithms you can develop on that. And of course the ambiguity. Okay, in order to translate the sentence to Kannada or Hindi, its ambiguity must be first resolved. So the person here in this picture says, call me a taxi please. So here this lady says, you want me to get you a taxi or tell you you are a taxi? So that is the confusion here. So here I would like to ಇಲ್ಲಿ ನಾವೊಂದು ನಮಗೆ ಕನ್ನಡದಲ್ಲಿ ಒಂದು ಹಾಡು ನೆನ ಬರ್ತದೆ. ಐ ಥಿಂಕ್ ಆಲ್ ಆಫ್ ಯು ಆರ್ ಅವೇರ್. ಎಲ್ರಿಗೆ ಕನ್ನಡ ಬರ್ತದೆ ಅಂತ ಅನ್ಕೊಂಡಿದ್ದೀನಿ ನಾನು, ಯಾರು ಕೇಳ್ತಾ ಇದ್ದೀರಿ ಅವರಿಗೆಲ್ಲ. ಸೊ ಒಂದು ಸ್ವಲ್ಪ ಹಿಂದೆ ಐ ಥಿಂಕ್ ಫ್ಯೂ ಇಯರ್ಸ್ ಬ್ಯಾಕ್ ನಮ್ಮ ವಿಷ್ಣುವರ್ಧನ್ ಸರ್ ಅವರದೇ ಒಂದು ಮೂವಿ ಸಾಮ್ರಾಟ್ ಅಂತ ಹೇಳುವಂತ ಒಂದು ಮೂವಿಯಲ್ಲಿ ಒಂದು ಹಾಡು, ಐ ಡೋಂಟ್ ನೋ ಹೌ ಮೆನಿ ಆಫ್ ಯು ರಿಮೆಂಬರ್ ಇಟ್ ಆರ್ ನಾಟ್. ಐ ಥಿಂಕ್ ಇಟ್ ವಾಸ್ ವೆರಿ ವೆಲ್ ಸಂಗ್ ಬೈ SPB ಸರ್, ಹಾಗೂ ಐ ಥಿಂಕ್ ದ ಲೇಡಿ ಸಿಂಗರ್ ವಾಸ್ ಸಮ್ ಮಾಲ್ಗುಡಿ ಶೋಭಾ ಆಗಿರ್ಬೋದು. ಸೊ ನಿಮ್ ಕಡೆ ಸಾಂಬಾರ್ ಅಂದ್ರೆ ನಮ್ ಕಡೆ ತಿಳಿಯೋದಿಲ್ಲ, ನಮ್ ಕಡೆ ಡಾಂಬರ್ ಅಂದ್ರೆ ನಿಮ್ ಕಡೆ ತಿಳಿಯೋದಿಲ್ಲ ಅಂತ. ಸೊ ಇನ್ ದಟ್ ಇಟ್ಸ್ ಅ ಬ್ಯೂಟಿಫುಲ್ ಸಾಂಗ್ ಆಕ್ಚುಲಿ. ನೀವು ಕೇಳಿ ಈ ಸೆಷನ್ ಆದ ನಂತರ ಕೇಳಿ. ಸೊ ದಿಸ್ ಇಸ್ ವಾಟ್ ಈಸ್ ಆಂಬಿಗ್ಯೂಟಿ. ಓಕೆ, ಸೊ ಆ ಸಾಂಗ್ ಅಲ್ಲಿ ಅವ್ರು ಏನ್ ಹೇಳ್ತಾರೆ, ನಿಮ್ ಕಡೆ ಶಿರಾ ಅಂದ್ರೆ ತಲೆ, ಹೌದು ಶಿರಾ ಅಂತ ಹೇಳಿದ್ರೆ ತಲೆ. ಸೊ ಒನ್ ಸೈಡ್ ದೇ ಟಾಕ್ ಅಬೌಟ್ ಶಿರಾ ಮೀನ್ಸ್ ಹೆಡ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಬಟ್ ಇನ್ನೊಂದ್ ಕಡೆ ನಮ್ ಕಡೆ ಶಿರಾ ಅಂದ್ರೆ ಕೇಸರಿ ಬಾತ್ ಅನ್ಕೋತೀವಿ. ಸೊ ಇಟ್ಸ್ ಆಂಬಿಗ್ಯೂಸ್. So you have shira means both. I can take it as kesari bath or you can take it as head. So again ಅದರಲ್ಲಿ ಮಾತಾಡ್ತಾರೆ, ಮಂಗಳೂರು ಸೈಡ್ ಅಲ್ಲಿ ಬೊಂಡ ಅಂದ್ರೆ ಇಟ್ ಇಸ್ ಎಳ್ನೀರ್ ಅಂತ ಹೇಳ್ತಾರೆ, ಬೊಂಡ ಬೆಂಗಳೂರು ಸೈಡ್ ಬೊಂಡ ಅಂದ್ರೆ ಆಲೂಗಡ್ಡೆ ಬೊಂಡ ಅಂತ. ಸೊ ಆಲ್ ದೀಸ್ ಆರ್ ಆಂಬಿಗ್ಯೂಸ್. ಸೊ ದಿಸ್ ಯಾಕೆ ಹೇಳಿದೆ ಅಂತ ಹೇಳಿದ್ರೆ, ಸೊ ಐ ಜಸ್ಟ್ ರಿಮೆಂಬರ್ ದಿಸ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಸಾಂಗ್ ಬಿಕಾಸ್ ಇಟ್ ಇಸ್ ಸೊ ವೆರಿ ಮೆಲೋಡಿಯಸ್. ಮತ್ತೆ ಅದರಲ್ಲಿ ಇದೇ ತರ ಈ ಆಂಬಿಗ್ಯೂಟಿ ಬಗ್ಗೆ ತುಂಬಾ ಮೆನ್ಷನ್ ಮಾಡಿರ್ತಾರೆ. But of course, the theme of that song was different. Even though we have so many differences, we should laugh, we have to be together ಅಂತ ಹೇಳುವಂತ ಹಾಡದು. But still, when I talked about this ambiguity, language translation ಗೆ, so I just remembered that particular song as a case study probably. So this is about the fundamental concepts. So I'll move on to my next session. Before that, if you have anything, the coordinators, if they have any doubts, you can ask me on this, or otherwise we can keep it at the end. That is also fine. Hello.
Sir, we have asked them to put the questions in the chat box and we will be taking at the end, sir.
Okay, Kandita. Then I'll continue with my next topic.
Okay, sir. Thank you, sir.
Yeah. Yeah. So once the fundamental concepts are clear, probably we'll move on to what are the models used in NLP. So why I have given this session, I mean added this session here is, see, it's not necessary. Let us assume you have a problem in natural language processing, and you need not learn all the models to solve a given problem. So you find out a problem and then check which model suits better. Of course, when you write a research article on that, probably most of us what we do is we take a problem and then we apply one methodology, and then we get some results. Then analysis ಮಾಡ್ತೇವೆ about various factors, and then we'll submit. ಆಮೇಲೆ ನಿಮಗೆ ಯು ವಿಲ್ ಗೆಟ್ ದ ಎಡಿಟರ್ಸ್ ರಿವ್ಯೂಸ್ ಅಂಡ್ ಆಲ್. ಓಕೆ, ಒಂದು ಕಾಮನ್ ಕ್ವಶನ್ ಇರ್ತದೆ, ವೈ ಡಿಡ್ ಯು ಚೂಸ್ ದಿಸ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಮಾಡೆಲ್? ಸೊ ನಾವು ದೆನ್ ಯು ನೀಡ್ ಟು ಪ್ರೂವ್ ಇಟ್. ಹೌ ಡು ಯು ಪ್ರೂವ್ ಇಟ್? ನಾವು ಮ್ಯಾಥಮೆಟಿಕಲಿ ಪ್ರೂವ್ ಮಾಡೋದು ಕೆಲವೊಮ್ಮೆ ಕಷ್ಟ ಆಗ್ಬೋದು, ಬಿಕಾಸ್ ಓನ್ಲಿ ಅಲ್ಗೋರಿಥಮ್ ರಿಲೇಟೆಡ್ ದೋಸ್ ಆರ್ ಡೂಯಿಂಗ್ ರಿಸರ್ಚ್, ದೇ ಪ್ರೂವ್ ಇಟ್ ಮ್ಯಾಥಮೆಟಿಕಲಿ ಅಂಡ್ ದೆನ್ ಗಿವ್. ಬಟ್ ನಾವು ಹೇಗೆ ಪ್ರೂವ್ ಮಾಡೋದು? ಬಿಕಾಸ್ ವಿ ಆಲ್ ವರ್ಕ್ ಆನ್ ಈ ಏರಿಯಾ, ಎಸ್ಪೆಷಲಿ ಆನ್ ನ್ಯಾಚುರಲ್ ಲ್ಯಾಂಗ್ವೇಜ್ ಮಷೀನ್ ಲರ್ನಿಂಗ್ ಅಂಡ್ ಆಲ್. ವಿ ವರ್ಕ್ ಆನ್ ಟೇಕಿಂಗ್ ಅಪ್ ಸೋ ಮಚ್ ಆಫ್ ಡೇಟಾ ಸೆಟ್ಸ್ ತಗೊಳ್ತೀವಿ. We are taking so many data sets, and on that data set we work. ಹೆಚ್ಚಾಗಿ ಡೇಟಾ ಸೆಟ್ಸ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ತಗೋತೀವಿ ನಾವು, ಹಾಗಲ್ಲ ಎನಿಥಿಂಗ್ ಇಂದ ತಗೊಂಡು ಡೇಟಾ ಸೆಟ್ ತಗೊಂಡು ಮಾಡ್ತೀವಿ. ಸೊ ದ ಬೆಸ್ಟ್ ಥಿಂಗ್ ಈಸ್ work on as much as data sets possible and then apply different techniques, different algorithms. Even when I talk about machine learning techniques, ನೀವು ಒಂದೇ machine learning ನೈ ಬೇಸ್ ಮಾತ್ರ ಮಾಡಿ ಅನಲೈಸ್ ಮಾಡೋದಲ್ಲ. ಸೊ you apply different algorithms on the same data set and then you only itself analyze. Avaga, so the editor or reviewers will definitely won't ask you that question, why I applied this, because in your paper yourself you have analyzed various algorithm on your data set, so they don't have those questions. Okay, so we'll see, but still for which NLP some problems, what type of models are best suited, we'll quickly run through, because I cannot explain you in detail in the short span of time, but still some overview I can give you so that you'll understand the concepts in detail. Yeah. So what are the various models available? Most important models are state machines, if you're going with rule-based models, logic probabilistic models, and vector space models. Of course, we are talking more on this probabilistic and vector space model. As I mentioned, state machines, you have finite automata, where if your system, you are working on chatbots and all, I think probably this works better. This can give you a better result. They're rule-based also. And Markov chain models and hidden Markov models. Typically, when you want to assign some tags to the words, I think these models would give you better results. And even in fact, you can go with maximum entropy models for classification. This one, and then you have machine learning algorithms also as for classifying, and then clustering, again deep learning, reinforcement learning, ಮಾಡಬಹುದು analysis ಗೆ use ಮಾಡ್ಕೋಬಹುದು. Yes, the very fundamental one I wanted to explain you in detail uh, is on n-grams. What is n-gram basically? As I already mentioned you, the difference between n-gram and bag of words. I'm taking this n-gram in detail. Now, once I explain you n-grams, so probably when you have this you can implement in your chatbot. So for example, your students or you're working on some standard chatbots, you can apply this on the chatbots, n-gram probabilistic models. So your chatbots can be more intelligent. When the particular user types one word, you can suggest him the next words. See, there are a lot of advantages when you suggest him the next words. What are the advantages? So when you suggest this one, your own word for him, typically he will go with that word only. So obviously our system's accuracy will increase. If you do not give him suggestions, whatever comes to his mind, he will type. So that is one advantage. Okay, so the accuracy of our chatbot system will be more whenever I will give him a suggestion, because whenever I give him a suggestion, he will go with that word only. Now we will see in how to give the suggestions using n-grams. N-gram, as I mentioned, is a sequence of n words. For instance, San Francisco is a 2-gram. The Three Musketeers is a 3-gram. She stood up slowly is a 4-gram. Now, if we assign a probability to the occurrence of an n-gram or the probability of a word occurring next in a sequence of words, it can be very useful us. Now, why it is useful for us? First of all, it can help in deciding which n-grams can be chunked together to form single entities, like San Francisco chunked together as one word, high school being chunked as one word. So it can guide me, oh, these are not two words, these are one words. Also, very important, maybe I don't know how much it is helpful for this, but this is of course of much useful for us. It can also help make next word predictions. Say you type something like this, say you typed please hand over your, okay, you typed that much, and the next it should give me what. So option is test, assignment, or paper. Okay, or it could be school. So it should give me a suggestion, either please hand over your test or assignment or paper, rather than giving me a suggestion as school. Correct? Because the probability that school appears after the sentences like please hand over your is very, very less. I can say that it is zero probability, right? Now, zero probability that the word school appears after the sentence. We will see how to do this. This is one use, okay? And then spelling error corrections also. One is you do that, uh, this one, what you call the differences, right? No, differences between two words. As I mentioned, that time you have the spelling corrections, spelling error, and then you have the distances between two words, Levestein or whatever it is, right? No, so those distance measures you are doing, okay? But otherwise, we can use n-grams also for that. So it can help making spelling error corrections. For instance, the sentence drink coffee. So F is missing here, could be corrected to drink coffee. If you knew in your sentences that the word coffee had a high probability of occurrence after the word drink, and also the overlap of letters between coffee and coffee is high. Okay, with this probability, I can say automatically correct it instead of drink coffee. So I'm not doing the distances between the two words and then doing the corrections. So I can just say that there is a high probability that after drink, either it can be coffee or could be tea or whatever. But since you already typed COFEV, there is a 100% probability that it should be coffee only. So correct it. Let us take one simple example. Okay, so to analyze n-grams, we must have a corpus of large sentences. Of course, with the 4 or 5 sentences, whatever analysis I am doing, it is not useful for us. But just to make you understand, I have given very simple sentences so that you understand this n-grams concepts clearly. For the purpose of our example, we will consider a very small sample of sentences, but practically or in reality, you're not supposed to do that. You must have a large chunk of training data. Now let us consider this example. He said thank you. This is what is the training sentence I have. He said bye, or training means what you have typed already. Say for example, today morning, afternoon you typed he said thank you. So at 2 o'clock you typed he said bye as he walked through the door. At 2:30 you typed he went to San Diego. At 3 o'clock in your mobile phone you typed San Diego has nice weather. At 4 o'clock you typed it is raining in San Francisco. And later at 5 o'clock you would like to type something. Okay, so what is the probability? It should start giving you suggestions now. It should start giving you suggestions based on these sentences. Okay, is that clear to you? I hope the concept is clear to you. Let us assume it is a bigram model. See, when you choose the model, no, n-gram, you can take it as bigram or trigram, that is left to you. Typically, we can go with the bigram model. Okay, so you want to like to give more and more word suggestions, you can go for trigram and so on. But I will explain you how exactly a bigram model works. Okay, so we are going to find the probability of a word based on probability of a word based only on its previous word. That is what is the bigram model. So in general, we can say that this probability is simple probability. There is no conditional probability, nothing here. The number of times the previous word WP, I refer but WP as the previous word here, occurs before the word WN. WN refers to the next word, divided by the total number of times the previous word WP occurs in the corpus. So the simple probability is count of WP WN divided by count of WP. Let us say, apply this. Now I told you at around half an hour back or 1 hour back you typed this. Now next moment you are trying to type something called thank. Okay, you are trying to type a word called thank. So your system, the mobile phone, should immediately give you a response, a suggestion as thank you. Correct? No, thank you. But what is that probability? So you need to check that probability. What is the probability that the next word is you? Okay, so you can just, if that probability could be calculated, then only you suggest, otherwise you don't suggest. So how do you find the probability? To find the probability of the word you following the word thank, we can write this as P. Okay, thank you. So this is the WN. Make a note of this. This is WN, next word. This is the previous word, WP. WP and WN, which is a conditional probability. Correct, no? So we have to find out what is the probability of the word you such that the previous word is thank. Conditional probability. So this becomes equal to number of times thank you occurs. Correct, no? That is according to our formula. What is the formula? Count of WP followed by WN. So number of times thank you occurs divided by number of times thank occurs. Correct? Number of times WP followed by WN divided by number of times the previous word occurs. So number of times thank you occurs divided by number of times thank occurs, 1 by 1, which is equal to 1 here. In this case it is 1, because you have seen how many times thank you occurs in the training sample. In the training sample, thank you occurs only once. Correct, no? thank you occurs only once, and out of, yeah, and the number of times thank occurs. How many times thank occurs in this? Thank occurs only once. So that means for the given training data set, I'm 100% sure that after thank only you should come. Okay. So, but the intention of the type user may be different. He may write thank Ramesh or thank whatever it is, but as a suggestion, there's nothing wrong to give, right? No. So as a suggestion, I'll say, because according to his usage and the training sample, I find that the probability is 100%. Okay, so I can say that with certainly that whenever thank occurs, he in his mind it is something like say you. Okay, it is something. So that's why I give him a suggestion called you. So whether to take that suggestion or leave that suggestion, it is left to the user. Let us calculate the probability of the word Jago coming after San. Same thing. So I'll not repeat it again. You can just see the probability Santiago, right now. So how many times Santiago occurs here? Santiago occurs. You can just see in the corpus, or sorry, the training data set. Santiago here occurs twice, right now, 1 and 2. And then the previous word San occurs. How many times San occurs? 1, 2, 3. So it should be 2 by 3. Right? So the probability that Jago occurs after San is 2 by 3, that is 0.67. Okay, so with that probability, and you may have some possible words after San, and you can compute the probability, and whichever probability is highest, you can suggest it. Okay, so that's what is the concept here. The same example, I give another example here. Yeah, let us quickly look into this toy corpus. This is the house that Jack built. This is the malt that lay in the house that Jack built. This is the rat that ate the malt, and so on. So we have some corpus here, or training data set. We call it as a toy corpus. Now, how do you consider example for the 4 grams here? Okay, 4 grams. So here the 4 grams example is considered. What is the probability that house appears after this is the? Because when I consider 4 grams, and I have to consider it as say 3 words and then followed by house. Okay, this is the house. So I need to find out the count of this is the, correct, no? This is the previous word WP and then WN divided by WP. This is the, so how many counts are there? This is the house. This is the house where we have this is the house. This is the house only one, right? No, one time occurrence. We don't have anything called this is the house there. So 1 divided by how many times WP occurs? This is the occurs 4 times. Here 1, 2, 3 and 4. Nowhere else this is the is there. So it is 1 by 4. Okay. So the probability that house appears after this is the is 1 by 4. So similarly, you can take some other possible words after this is the, calculate its probability, and whichever highest probability is there, you give the suggestion. So this is bigram. Same thing, same example with bigram. He has taken it as that Jack. Okay, that Jack. So that is the previous word and Jack is the next word. So that Jack occurs 4 times. You can see 1, 2, 3, 4, and then that previous word occurs 10 times. So it is 4 by 10. Now the very important is, see, you have seen the situations where we type one word and it gives me one more word as suggestion. But if you see Gmail, probably sometimes it so happens that when you start writing one word, nowadays it is trying to give you the full sentence as the suggestion, right? No, full sentence as the suggestion. So how it gives? So we will see such things also here now. What is the probability of the whole sequence of words in a particular sentence? So that probability we need to compute. Now, see here, I have a sentence called this is the house. Now I need to find out the probability. What is the probability that this sentence is formed? What is the probability that this sentence is formed? That is, this followed by is, followed by the, then followed by house. What is it? Probability. And to do this, how should I start with? How is to start with this? What is the probability of this particular term, this? Then the probability of this followed by is, then the probability of this is followed by the, then this is the followed by house. Now imagine if the sentence is too long, you may have so many probability values to compute. Right now, let us see. This is what is happening. Chain rule. Predict probability of a sequence of words. W is equal to W1 into W2 into W3 up to Wk. And we apply the chain rule as I mentioned, right now. So for the words, for this probability of this followed by is, that's what is mentioned here, W2 bar W1, and then this is the, right? So that is also given, and so on. In general, it could be W key bar K bar W1 to Wk minus 1. So here the drawback is for suppose the sentences are possible, all probabilities we need to calculate, correct? No, this, then this followed by is, then this is followed by the, then this is the followed by house. Okay, so and there is a solution for this, and the solution is Markov assumption, Markov chain model. Okay, so this is very important here. What the Markov assumption says that is, you need not consider all the possible previous words. So for example, I'm trying to find out the probability of the, and he says Markov assumption says that don't look into this and is, you look into only is. And whenever I would like to find out the probability that occurs after this is the, he says just look the probability with the house and the, don't look into this and is. So that is what is the Markov assumption. Right now, so Markov assumption says you shouldn't care about all the history, you should just forget it. You should just take the last n terms and condition on them, or to be correct, last n minus 1 terms. So this is where they introduce assumption, because not everything in the text is connected. With that assumption, we go further. So now for the same problem, what we do, the chain rule will not use it, and then we use the Markov assumption. Markov assumption is only for that with the previous one. So you can just see previous is Wi, and the next one is Wi minus n plus 1 and Wi minus 1. Example, we'll consider this example now, it will be clear. Bigram language model. Now, I have a very simple training set. This is the malt, and that lay in the house that Jack built. Of course, practically, this is, I cannot judge on these only to these two sentences to give you the suggestions. Of course, see, in our real time also same thing, right? So when I want to give you some suggestions, so I must be trained very well. So unless I trained very well, how can I give you suggestions? So you may ask me at the end of the session, you may ask me so many questions. Now, unless I'm not trained, I cannot give you the suggestions. Of course, I may not be able to give you the suggestion even today also. That is different thing. But still, based on my knowledge, based on my work experience, probably I can give you some suggestions. Even the Bigram language model also is the same thing. Okay, so in this case, say now I'm not finding out, I'm not taking a suggestion for one word. Okay, I am giving a suggestion. What is the entire probability that this sentence is framed? This is the house. So that means now when I start typing something, okay, this sentence should come in front of me as a suggestion. So, and that what is the probability that this sentence comes? I have to compute. Okay, so probability of giving a sentence like this is the house is equal to probability of this occurring into and, because it's independent words, that's what is the condition, and only with that condition I can multiply. Right now all of you are aware that in the probability they are independent, then only I can multiply. So probability of this, and now I have to compute what is the probability that is followed by this. Okay, is followed by this, so that's it written here. And now when I go next, I'm not computing what is the probability of the followed by this is, Markov assumption. Okay, I'm applying Markov assumption, and I'm writing what is the probability that is, sorry, the is followed by is. You can see here. Okay, only current and previous, that's it. Okay, just the best example for us also, human beings. Otherwise we keep remembering everything, what 10 years back what has happened, 20 years back what has happened. Right now Markov assumption says forget everything, just remember today and yesterday, that's all. Okay, or tomorrow, and you predict what is the next one right now. So that's what it says. And here same thing, the probability, house and the see here, next word is house and the previous word is the. Okay, now compute the probability. What is the probability that the word coming is this here? Very simple. How many times this has occurred? Once. How many total words are there in the training set? 2 4 6 8 10 12 12 ಇದೆ 1 by 12 into condition. Illi condition illa because this is the first word. So here you have a condition. Okay, so what the condition says, how to compute the probability? Count of what? Previous word followed by the next word, previous word followed by the next word. So that is, what is the previous word? This is, right now this is. How many times this is occurred? Only once, right? And how many times the previous word has occurred? Previous word is this occurred how many times? Once, one by one. So andre, whenever this occurs, 100% probability that the next word is always is in this training center. Similarly, this is the, right now previous is, next is the, how many times is the occurred? One, right? And then how many times the previous is occurred? Is also occurred once. And similarly here, the house, right now the house, how many times? The previous is the house, how many times the house has occurred? The house has occurred only once. And then the how many times occurred? Twice. Here one, here one, two, 1 by 2, and you multiply, and that is the probability with which this particular sentence has occurred. Okay, so I have another example. Probably I think I'll be able, I thought of giving you as an assignment that you can compute it. Okay, if you have a snapshot you can keep of this in the screen. Okay, you can keep a snapshot and keep it. The training set is this: the Arabian Nights. These are the fairy tales of the East. The stories of the Arabian Nights are translated in many languages. Okay, so now what is the probability that the sentence, this one, the Arabian Nights are the fairy tales of the East? Say for example, meaning what I start typing, no, my system should give you this suggestion. So what is the probability that the user thinks to write this particular sentence? So you are giving a suggestion. So you can compute it, as I mentioned. For this you can compute for the entire sentence, and it comes to roughly around 0.00268 probability. Okay, maybe on the snapshot ತಗೊಳ್ಳಿಕ್ಕಾಗುವುದಾದ್ರೆ ತಗೊಂಡ್ಬಿಡಿ, this one and this, or otherwise I can share you later. Yeah, so another model we have is the Markov chain model. Okay, Markov chain model, as I mentioned, which is very lightweight. Why it is lightweight is it doesn't remember the entire sequence of words. I mean, all state information it doesn't remember. It remembers only current state and previous state. That's it. Okay, so I mentioned that one of this technique I used it for one of the objective of my research work. In fact, I was having a problem to develop a parts of speech tagger on the mobile device itself. And whenever I wanted to develop a parts of speech tagger on a mobile device, I had lot of challenges. The one challenge was of course computational power, and second challenge was the amount of burden on the storage also it was having. So one is computation and second one is storage, because of the, if you consider the Stanford parts of speech tagger and all, there's a lot of corpus coming along with that particular API. You can run on servers, no issues, but whenever I wanted to do that particular computation on the fly on the mobile device, it was not possible for me. And then I have designed my own parts of speech tagger using simple Markov chain model. And it was not a generic parts of speech tagger. It was related to one particular module, and hence it has to be lightweight, and that's why I use Markov chain model. And if anybody is interested to read that work, you can refer to the paper which is available again in ResearchGate also. You later if you'd like to read that, if you'd like to, anybody would like to work on parts of speech taggers, you can read that, you can communicate to me, I'll just share that with you. So as I mentioned, for Markov chain is a lightweight probabilistic model which is used to predict the next states. Let us take a very simple example to make you understand this Markov chain model. So if you knew that the weather for the past 3 days was sunny, sunny and foggy in chronological order, the probability that tomorrow would be rainy is given by this, right? No, so it says very simple, you have to predict tomorrow. So Q4, I can say day 1, day 2, day 3 and day 4, Q4 is equal to rainy. Given a condition, there is some condition. What is that condition? The past 3 days where Q1 was sunny and Q2 was sunny and Q3 was foggy, and you have to compute this. So the Markov chain model would be the best one. Yeah, so here we have some issue with this. The larger n is, the more observations we must collect, right? As I mentioned in the previous example, the sentence is very long, so many possibilities we need to take, and we need to generate the probability. But as I mentioned, Markov chain does a very simple assumption. It just requires the current state and the previous state. That's it. So we'll try to solve this now. Yeah, and of course the probabilities, it has to multiply. Okay, so we'll see this example. Let us take this example. You have today's weather, say it could be sunny, it could be rainy, or it could be foggy, and tomorrow's weather, say rainy, sunny, rainy and foggy. You may ask me, sir, how did you get these values? Don't worry about how did I get these values. This is some probabilistic values I got, probably using regression techniques, probably might have got these values. No, we are not bothered about this. Okay, it is something like I got this probability values now. So I say that today is sunny, and what is the probability that tomorrow is sunny? Is 0.8. And today is sunny, what is the probability that tomorrow is rainy? It is 0.05. Then today is sunny, what is the probability that tomorrow is foggy? Is 0.15. Using some regression or analysis, I have computed this. Now, what I do is I use Markov chain model and do some more analysis here. You can just see. So I just create a state transition probabilities. It's simple. Okay, just a conversion of this particular table into state transition diagram. So you can see here, today is sunny. Okay, so that's the probability. So suppose you have some today the state as sunny, with the 0.15 probability it goes to foggy. Okay, see this you can map to our real-time situations also. We have what I have done in my work is same thing. So I have a current word now. Let us assume the current word is noun. What is the probability that the next coming word is a verb? So that computation I had done. So this is what is the this one analysis I have done there. So here also same thing. So what is the probability that the next word is foggy, and suppose you have a foggy state, what is the probability that it is going to be sunny? So it says, so with the 0.2 probability it is sunny, with the 0.3 probability it would be rainy, and with the 0.5 probability it would be foggy itself, with the 0.8 probability it would be sunny itself, and with the 0.05 probability it could be sunny and rainy and so on. So I have just constructed this particular state transition diagram. Now I can do some analysis. As you can see, say some intelligent question come. Given that today the weather is sunny, what is the probability that tomorrow is sunny and the day after is rainy? Okay, so if you weather is today is sunny, tomorrow what is the probability tomorrow is sunny? It is given. There is absolutely no problem. But he asks, and what is the probability that day after is rainy? So using Markov assumption, how we can write? It's the probability, right? No. So what I have to predict? Probability of Q2, that is day 2 sunny and day 3 rainy, given a condition that today is sunny, correct? No, today is sunny. So you can write it as I told here. It is mentioned in this formula. No, formula is you have to all the probability, that is the probability you have to do multiply, and I am doing the same thing. What it does, probability of, yes, so this is what you have to do. Probability of Q3 is equal to rainy, given condition that Q2 is equal to sunny and Q1 is equal to sunny, because he is asking what is the day after, right? Day after is, right? Q3, and of course you have to write this, what's the probability that tomorrow is sunny? Probability of Q2 is equal to sunny, given a condition Q1 is equal to sunny. So now here if you observe, now he is interested in this formula or this probability equation, is interested in knowing Q1 also, Q2 also, and Q3 also. So what the Markov assumption says is, see, you bother only about Q2 and Q3, why you are bothered about Q1? So you apply Markov assumption here, and probability of Q3 is equal to rainy, given a condition that Q2 is equal to sunny. That we compute. And then here Q1 is equal to sunny and Q2 is equal to sunny. So this is what is the probability we will compute. Okay, so then that means the Q1 is not at all necessary for me. Q2 I take and Q3 I'll take, and then the product. So this is what one example. Similarly, I have another example. I'm not going to explain this. Okay, anyhow, later I'll share you the slides. You can just go through this. So fine. Again, hidden Markov model is very important topic, but this HMM model itself will take a lot of time, and so I think I have 20 more minutes with me, and so it's may not be able to finish this HMM model. So I'll just skip this, but I'll go to another important model which is required for your machine learning analysis. Okay, and that is yeah, thus bag of words and term frequency and inverse document frequency. Let me just touch upon on this for some 10 minutes and then we'll stop. Yeah, so we have discussed about bag of words, and I told you this bag of words and term frequency and inverse document frequency contribute a lot, because whenever you want to apply machine learning algorithm on text processing, okay, you must understand this bag of words and turn frequency and inverse document frequency concept. It's very easy. There is nothing rocket science here. Okay, so machines cannot process text data in raw form. It's difficult. So we need to break them down into the text into a numerical format that is easily readable by the machine. And this is where the concept of bag of words and turn frequency and inverse document frequency come into play. So both bag of words and turn frequency and inverse document frequency are techniques that help us convert text sentences into numeric vectors. We'll take some examples, that time it will be clear to you. So here is a sample reviews about a particular horror movie, say. Review 1 is, this movie is very scary and long. Review 2 is, this movie is not scary and is slow. Review 3 is, this movie is spooky and good. Some 3 random reviews I have taken into consideration, and now I'm not explaining you how do I classify it as positive or negative. That is not a part of this session, but I will explain you how do you prepare the data for the machine learning algorithm. Okay, how do you prepare this data for the machine learning algorithm? So when can you give simply these 3 sentences to machine and then tell me, hey, please tell me how do you classify it as positive or negative? So that is not possible right now. So the machine will not understand anything. So we need to perform certain text pre-processing steps here. And of course, before I do this particular IF, TDF, TF, IDF and bag of words, make sure that the unnecessary is this and all things can be removed. Okay, can be removed. That whatever I told you, that stop word removal earlier, you can apply, and then you can apply this particular TF, IDF. That is always better. Creating vectors from the text. The basic requirement would be, it should not result in a sparse matrix, since sparse matrices result in high computation cost. So whenever I prepare this particular TF ideas, make sure that you don't result don't I mean that particular vector doesn't result in a sparse matrix. Sometimes our training samples are so bad that it results in a sparse matrix, and our efficiency of the computation goes really down. So we should be able to retain most of the linguistic information which is present in the sentence. We'll see two models. One is the bag of words model. The bag of words model is the simplest form of text representation in numbers. Like the term itself, we can represent a sentence as a bag of words vector. Now, let us recall all our three movies reviews. Review one is this movie is scary and long and so on. So this particular vocabulary, this is the training set for me now. This is the training set for me. So the vocabulary consists of 11 words. Some of them repeat, right? No, I'm talking about, so don't write again this 3 times. This write only once. Like that, you movie repeats twice. So, but unique words you write here. This movie is very scary and long, not slow, spooky, good. But here I have not applied the stop word removal. If I have applied stop word removal, I think my vocabulary would be much smaller. And then I compute this. Okay, this movie is very scary and long, not slow, spooky, good. These are the various words I constructed, 11 words, unique 11 words right now. And then I just document one. So you might have various documents or various tweets. If you're working on Twitter data, you may have various tweets, or you may have various reviews if you're taken the reviews from Amazon or any others, right? Any other one, or movie reviews or anything. So here it's very simple. Review one, this occurred once, movie occurred once, is occurred once, very scary occurred once, and not this, it's not occurred in review one, slow not occurred, and hence it is 0. And length of the review in words is 7. Similarly, review 2, you can just see is occurred twice, correct? No, is occurred twice. This movie is not scary and is slow, and we have a count here. So this is the vector. So vector for review 1 would be 111, 111, 10007. Okay, and 11200. This I prepare now. This vector I prepare, and I am ready for the machine learning algorithm. Now, this vector, when I prepare, I am ready to implement the naive Bayes or SVM or any other machine learning technique based on this. Okay. What is a drawback? See, I have not explained again. I am just stopping here because this is what is the data preparation for my machine learning model. Drawbacks of using this bag of words model. What are the drawbacks? We can have vectors of length 11 in this example. However, we start facing issues when we come across new sentences. If the new sentences contain new words, then our vocabulary size would increase, and thereby the length of the vectors would increase too. Additionally, the vectors would also contain many zeros, thereby resulting in a sparse matrix, right? No? So now let us assume that there are so many words you have kept, and for some reviews, you can see that most of them will be zeros because those words never appear in those particular reviews. So that's a big headache here in this model. So we are retaining no information on the grammar of the sentences nor on the ordering of the words in the text. Of course, for the third point, we are using n-grams. If you want to maintain the ordering of the words, you cannot go for bag of words. You have to go with the n-grams. And the various problems which can be solved using n-grams, then only you go for that. Otherwise, if you machine learning concepts, we use this. Another technique, we use term frequency and inverse document frequency. So in this particular word count or bag of word, we are not specifying how a word, I mean, how important a word is to a document. That importance we are not mentioning, we're simply giving the count. But in this term frequency and inverse document frequency, I am just specifying how important a word to a document in a collection or corpus. So that is the benefit of using term frequency and inverse document frequency. Let us look into what is term frequency. So it's a measure of how frequently a term T appears in a document T. So it is computed as a term frequency, particular term, I can see here, you can see here term, and then a document is equal to the number of times, right now, the numerator, you can see the number of times the term occurring in that particular document divided by number of terms in the document. Okay, that is what is TF. So again, we'll take some small example. Okay, we'll just take only for review to say this movie is not scary and is slow. Now number of words in review 2 is 8, and term frequency for this word, this number of times this appears in review 2 divided by number of terms in review 2, which is 1 by 8. So that is the term frequency. So similarly, you can compute for all right now in this review 2, and you can have a table for this. So these are all the possible terms, 11 terms, which can occur across all three reviews, 11 words. And then in review 1, how many times it has occurred? Review 2, it has occurred. Review 3, it has occurred. And then you calculate the term frequency for review 1. Okay, this is the term frequency. And for review 2, what is the term frequency? And review 3, what is the term frequency? This is how we can compute. Now let us see what is inverse document frequency. Inverse document frequency is a measure of how important a term is, as I mentioned. So inverse document frequency for a term is calculated as log of number of documents divided by number of documents with the term T. I repeat, number of documents divided by number of documents with the term T. So you can compute it, say for review 2, say let us assume you are computing idea for this is equal to log of number of documents divided by number of documents containing the word this is equal to how many documents are there? 3 reviews. I can say 3 reviews divided by number of documents containing the word this 3. So log of 1 is equal to 0. And then hence you compute for all others. So you can see you can just see how important that word is in that document right now. So that's inverse document frequency. Now you can have a product. Okay, you can see here, we see that the words like is, this, and, etc. are reduced to 0 and have little importance, and that's why we use them to remove in our stop word removals, while the words scary, long, good, etc. are words with more importance and thus have a higher value. You can just see right now IDF, you can just see some of the words very, scary, long, not, slow, spooky, good. Okay, some others which may not have that importance will be converted. I mean, the value should be 0. So we can now compute the product of these two, okay, TF and IDF, and then you can see that higher score having more important with the lower score are less important in that document. Of course, this document you can use these concepts also, you can use for document uh, uh, summarization also. Yes, so we can compute it. I think the final table is given here. Okay, you have the IDF, okay, and then TF IDF. So you can compute the product TF IDF for this review one. You can see very few values you have here which are specifying the importance. Other values are not important for that document. Okay, so this table will be again given to the machine learning algorithms. Again, the machine learning algorithms may use bag of words, it may use only term frequency, or it may use term frequency and IDF based on your requirements. So suggestion is, what you can do is, you have large text to analyze, you can apply, say for example, bag of words and then term frequency, or and then multiply IDF and then analyze, and then you can give you a comparative results. Okay, see, this is the data I had, and then I had applied this bag of words, and then I applied term frequency IDF, and this is what is the variation I'm going to get for my data set. So summary, bag of words just creates a set of vectors containing the count of word occurrences in the document reviews, while the TF-IDF model contains information on the more important words and the less important ones as well. But bag of words vectors are easy to interpret. However, TF-IDF usually performs better in machine learning models. So thank you. I could not cover up hidden Markov model because it takes a lot of time again. So I think with the given time, I tried to cover up most of the fundamental things. See, again, here I have not touched anything on machine learning. You can see in this, I have not touched anything on machine learning, but I had prepared a model on which you can apply machine learning algorithms. Okay. So that's it. Now, if you have anything to ask, I think you have 8 more minutes. I think I finished, yeah, 7 more minutes. So I think that we can reserve for solving your doubts. Or if you have anything, you can contact to my mail ID also, which is with the coordinators. Feel free to mail and then share,
Sir,
exchange the
excuse
ideas.
me,
Yeah,
there is a question from Kasturi Rangan.
yeah.
Is there any standard data sets available publicly for Indian regional languages, especially in Kannada, sir?
ಕನ್ನಡಕ್ಕೆ I doubt, sir, but you can just check once in Kaggle ಅಲ್ಲಿ ಒಮ್ಮೆ ನೋಡ್ಕೊಂಬಿಡಿ. You have any data set available for ಕನ್ನಡ, but ಈ local regional languages ಗೆ ಸ್ವಲ್ಪ ಕಡಿಮೆ ಸಿಗೋದು ಕಡಿಮೆ. Even for Sanskrit and Dravidian languages ಗೆ ಕೂಡ ಸ್ವಲ್ಪ ಕಡಿಮೆ, but there is available because one of my student is working on Tulu language actually, ನಮ್ದು local. So we are also finding it great difficult. ಅಲ್ಲಿ ಏನಾಗ್ತದೆ ಅಂತ then we have to generate our own data sets. Data set prepare ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ಟು ಮತ್ತೆ we have to continue. But for Kannada, I don't think so ಅಷ್ಟು ಪ್ರಾಬ್ಲಮ್ ಆಗ್ಲಿಕ್ಕಿಲ್ಲ. ಕನ್ನಡಕ್ಕೆ ಡೇಟಾ ಸೆಟ್ ಅವೈಲೇಬಲ್ ಇರ್ತದೆ. ತುಂಬಾ ಇರ್ಲಿಕ್ಕಿಲ್ಲ. ಇಂಗ್ಲಿಷ್ ನಷ್ಟು ನಿಮ್ಗೆ ಸಿಗೋದಿಲ್ಲ, ಬಟ್ ಸಮ್ ಎಕ್ಸ್ಟೆಂಟ್ ಕನ್ನಡಕ್ಕೆ ಖಂಡಿತವಾಗಿಯೂ ಸಿಗ್ತದೆ.
Okay, sir. Thank you. Sir, there is another question from HM Kirti Kumar.
ಹೇಳಿ ಸರ್.
He is asking whether in between TF and TF underscore IDF, which is better to use?
That depends, sir, what data set you're using and what machine learning you're using. That's what I told you when I was just finishing my slides. I told you that usually now direct agi ಹೇಳಲಿಕ್ಕೆ ಆಗಲ್ಲ, because that all work differently on different data sets, sir. ಸೊ ಅದಕ್ಕೆ ನಾವು ಏನ್ ಮಾಡ್ತೀವಿ ಅಂತ ಹೇಳಿದ್ರೆ, ವೆನ್ ವಿ ರೈಟ್ ಸಮ್ ಪೇಪರ್ಸ್, ಆರ್ಟಿಕಲ್, ರಿಸರ್ಚ್ ಆರ್ಟಿಕಲ್ ಬರೆಯುವಾಗ ನಾವು ಒಂದೇ ಮೆಥಡ್ ಅಪ್ಲೈ ಮಾಡೋದಿಲ್ಲ. ಅದಕ್ಕೆ ನೀವು ಏನ್ ಮಾಡಿ ಅಂತ ಹೇಳಿದ್ರೆ, ಯು ಅಪ್ಲೈ ಆಲ್. ಸೊ ಬ್ಯಾಗ್ ಆಫ್ ವರ್ಡ್ಸ್ ಯೂಸ್ ಮಾಡಿ ಮಷಿನ್ ಲರ್ನಿಂಗ್ ಅಪ್ಲೈ ಮಾಡಿ, TF ಅಪ್ಲೈ ಮಾಡಿ ಮಷಿನ್ ಲರ್ನಿಂಗ್ ಅಪ್ಲೈ ಮಾಡಿ, TF IDF ಅಪ್ಲೈ ಮಾಡಿ ಮಷಿನ್ ಲರ್ನಿಂಗ್ ಅಪ್ಲೈ ಮಾಡಿ. ರಿಸಲ್ಟ್ಸ್ ವಿಲ್ ಬಿ ಇನ್ ಫ್ರಂಟ್ ಆಫ್ ಯು. ಯು ಕ್ಯಾನ್ ಕಂಪೇರ್ ಇಟ್, ಸರ್.
Dear participants, if any other questions are there, kindly post it in the comment section so that we can take up the questions.
So otherwise also they can mail it to me, sir. No problem. Feel free to
Okay, sir.
contact me at any time. ಏನು ಸಮಸ್ಯೆ ಇಲ್ಲ, ಫೋನ್ ಮಾಡಿ ಮಾತಾಡಿ. ಖುಷಿ ಆಗುತ್ತೆ ನನಗೆ when we talk, when you send mail. ನಮ್ಗೆ ಏನು ನಾಲೆಜ್ ಇದೆ that I will share absolutely. So I hope this session was fruitful for you. Then I think ತಮಗೂ ಖುಷಿ ಆಗ್ಬೋದು.
I sincerely thank our resource person, Dr. Roshan Fernandes, who is an associate professor in Department of CSE in NMAMIT Nitte, for his kind dedication and enlightening session on basics of NLP. So I think this session, which is the first session of our workshop, is a successful session, and it will be a fruitful for our participants too. They can make it example. That's an whatever the examples he has given. So it was very interesting examples, and it was very much interesting session. So I thank our resource person on behalf of our college. Thank you, sir.
ಥ್ಯಾಂಕ್ ಯು. ಧನ್ಯವಾದಗಳು ನಿಮಗೂ, ಎಲ್ಲ ಸ್ಟಾಫ್ ಮೆಂಬರ್ಸ್ ಫ್ರಮ್ ವಿದ್ಯಾವರ್ಧಕ್. ಸೊ ಬಹಳ ಒಂದು ಕೀ. ಯೆಸ್ಟರ್ಡೇ ಇಟ್ ಸೆಲ್ಫ್ ಯು ಚೆಕ್ ದ ಕನೆಕ್ಟಿವಿಟಿ ಅಂಡ್ ಆಲ್. ಥ್ಯಾಂಕ್ ಯು. ದಟ್ ಶೋಸ್ ದ ಸೀರಿಯಸ್ನೆಸ್. ಇಲ್ಲಾಂದ್ರೆ ಸುಮ್ಮನೆ ನಾವು ಬರೋದು, ಇವತ್ತು ಟ್ರೈ ಮಾಡೋದು ಕಷ್ಟ ಆಗ್ಬಿಡುತ್ತೆ. ಮತ್ತೆ ತುಂಬಾ ಥ್ಯಾಂಕ್ಸ್ ಟು ಆಲ್ ದ ಪಾರ್ಟಿಸಿಪೆಂಟ್ಸ್ ಆಲ್ಸೋ. ನನಗೆ ಒಂದೇ ಡ್ರಾಬ್ಯಾಕ್ ಅಂದ್ರೆ, ನನಗೆ ಯಾರು ಪಾರ್ಟಿಸಿಪೆಂಟ್ಸ್ ಇದ್ದಾರೆ ಅಂತ ನನಗೆ ಯಾವತ್ತೂ ಗೊತ್ತೇ ಆಗಿಲ್ಲ. ಇವನ್ ಐ ಕುಡ್ ನಾಟ್ see. That is the only one drawback. Wish we could do this on offline alva. Offline ಆಗ್ತಿದ್ರೆ ತುಂಬಾ ಇನ್ನೂ ಇಂಟ್ರಾಕ್ಷನ್ ಆಗ್ತಿತ್ತು. So I could not
we
see.
had planned for offline, sir, but due to second wave of COVID.
ಇಲ್ಲ ಖಂಡಿತವಾಗಿಯೂ ಅಲ್ಲ. This is what is the suggestion. Only I could not see the faces of the participants. We wish
we will
that
really
in future,
look forward for your offline sessions too, sir. If possible, we will try to do it in offline also.
ಖಂಡಿತ. ಮೈಸೂರು ಅಂದ್ರೆ ಬಹಳ ಖುಷಿ ನಮ್ಗೂನು. ಯಾಕಂತ ಹೇಳಿದ್ರೆ that is the one place where I pursued my MTech, and one of the best places I think all like. So thank you so much. Wish all the participants all the very best for their work, and ಬಹಳ ಚೆನ್ನಾಗಿ ಒಂದು ವರ್ಕ್ ಮಾಡಿ. ಮೇ ಬಿ ಯು ಕ್ಯಾನ್ ಟೇಕ್ ದ ಲೋಕಲ್ ಲ್ಯಾಂಗ್ವೇಜಸ್, ಯಾಕಂತ ಹೇಳಿದ್ರೆ ಕನ್ನಡ ಬಗ್ಗೆನೂ ತುಂಬಾ ವರ್ಕ್ ಮಾಡ್ಬೋದು, ಕನ್ನಡಕ್ಕೂ ಮಾಡ್ಬೋದು. ಈವನ್ ಕೂರ್ಗ್ ಲ್ಯಾಂಗ್ವೇಜ್ ಅದು ಇದೆ ನಮ್ಮ ಕರ್ನಾಟಕದಲ್ಲಿ. ಮತ್ತೆ ತುಂಬಾ ಅಂದ್ರೆ ಈ ಡಿಫ್ರೆಂಟ್ ವೆರೈಟಿ. ಈಗ ನಾನು ಹೇಳಿದಾಗ ಒಂದು ಹಾಡು ನೀವು ಕೇಳಿ ಎಲ್ರು, ಒಂದು ಸಾಮ್ರಾಟ್ ಮೂವಿ ಇದ್ದದ್ದು, ಅದು ಯು ಲಿಸನ್ ಟು ದಟ್ ಸಾಂಗ್, ಇಟ್ಸ್ ವೆರಿ ರಿಯಲಿ ಬ್ಯೂಟಿಫುಲ್ ಸಾಂಗ್. ಅದರಲ್ಲಿ ಒಂದು ಡಿಫ್ರೆನ್ಸಸ್ ನೋಡಿ. ನಮ್ಮ ಕನ್ನಡದಲ್ಲಿ ಮಂಗಳೂರು ಸೈಡ್ ಏನು ವರ್ಡ್ಸ್ ಯೂಸ್ ಮಾಡ್ತೇವೆ, ಬೆಂಗಳೂರು ಸೈಡ್ ಏನು ಯೂಸ್ ಮಾಡ್ತೇವೆ, ಬೆಳಗಾವಿ ಸೈಡ್ ಏನು ಯೂಸ್ ಮಾಡ್ತೇವೆ, ಅದು ಬಹಳ ಚೆನ್ನಾಗಿ ಒಂದು ರಿಟರ್ನ್ ಇನ್ ದಟ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಸಾಂಗ್. ಪ್ರಾಬ್ಲಿ ಹಂಸಲೇಖ ಸರ್ ಹ್ಯಾಸ್ ಕಂಪೋಸ್ಡ್ ಇಟ್. ಸೊ ಅಂದ್ರೆ ನಮ್ಮ ಈ ಕನ್ನಡದಲ್ಲೇ ತುಂಬಾ ವಿವಿಧತೆ ಇದೆ. ಸೊ ಪ್ರಾಬ್ಲಿ ಯು ಕ್ಯಾನ್ ವರ್ಕ್ ಮೋರ್ ಆನ್ ದಿಸ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಕನ್ನಡ ಸ್ಕ್ರಿಪ್ಟ್, ಅಥವಾ ನಮ್ಮ ಲೋಕಲ್ ತುಳು ಆಗ್ಬೋದು, ಕೋಸ್ಟಲ್ ಅಥವಾ ಕೊಂಕಣಿ ಆಗ್ಬೋದು, ಎನಿಥಿಂಗ್. ಸೊ ಪ್ರಾಬ್ಲಿ ನಮ್ಮ ಒಂದು ಭಾಷೆಗೆ ನಾವೇ ಒಂದು ಸ್ವಲ್ಪ ಡೆಡಿಕೇಶನ್ ಮಾಡಬಹುದು ಅನಿಸ್ತದೆ. ಸೊ ಹಾಗೆ ಮಾಡಿದ್ರೆ ಪ್ರಾಬಬ್ಲಿ ಸಮ್ ಕಾಂಟ್ರಿಬ್ಯೂಷನ್ ಆಫ್ ಕೋರ್ಸ್ ಅದ್ ಮತ್ತೆ ನಮಗೆ ಪಬ್ಲಿಕೇಶನ್ಸಿಗೂ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ, ಸೊ ವರ್ಕಿಗೆ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ, ಎಲ್ಲವೂ ಆಗುತ್ತೆ. ನಿಮ್ಮ PhD ಅಥವಾ ರಿಸರ್ಚ್ ಅನ್ನು ಮುಂದುವರಿತದೆ. ಸೊ ಇಷ್ಟು ಹೇಳಿ ಐ ಥಿಂಕ್ ಐ ವಿಲ್ ಸ್ಟಾಪ್ ಹಿಯರ್. ಥ್ಯಾಂಕ್ ಯು ಫಾರ್ ಯುವರ್ ಪೇಷಂಟ್ ಲಿಸನಿಂಗ್. ಯಾ, ಥ್ಯಾಂಕ್ ಯು.
Thank you, sir. Thank you very much.
Yeah. So with your permission, can I log off, sir?
Yes, sir. You can, sir. Thank you very much, sir.
Yeah. Thank you.
Dear participants, regarding the feedback of this particular session, we will be posting the link in this chat box itself and also in the WhatsApp group. Kindly give the feedback for this session. So, and tomorrow at the same time, that is at 2:30, we will be having a second session, and we look forward for your kind support and your presence in the same way how you have given us in the first session. Thank you very much.